Bismillah. Okay, let us continue from where we left. We are now to start on question number 12, the same paper which was done in the year 2018, mathematics paper 1. So, as far as the question is concerned, we have a question which read, use matrix method to solve. So, we are to solve this equation by matrix method. These are a pair of simultaneous equations. So, how are we going to solve by matrix method? So for matrix method, we need to write the equation given in matrix form. We need to write the equation given in matrix form. So the equation states 5x plus 3y is equivalent to 35 and 3x minus 4y is equivalent to negative 8. So we are going to consider the variables. The variables are x and y, but the coefficients are here. We have 5, so we write the coefficients. Here we're going to have 5. The other coefficient is 3 for the 3y, so we write 3 here. And then we have 3x, so we're going to write 3 minus 4y, so we write negative 4. These are the coefficients. And then we are going to enclose these ones in a matrix form like that. We open another bracket to introduce the unknowns, which are x. Another unknown here is y. We close the bracket. It is all equivalent to the constant matrix, which is on the right hand side of the equation. That is 35 and negative 8. We write it in column form like that, and then we introduce a bracket. So this is the first step. We are going to write the equations in matrix form, and this is the matrix form. We then look for the determinant, inverse of this matrix. But for you to have an inverse, you need to get its determinant. So the determinant is given by, abbreviated as DET. It is given by the elements in the main diagonal, their product, that is, minus the product of the element in the other diagonal. So the main diagonal is that which runs from top left to bottom right, from 5 all the way to negative 4. We call it the main diagonal. So we're going to have 5 times negative 4. My dot here means times, minus the answer we are going to get here. We are going to subtract 3 times 3. This one is the secondary diagonal, that which runs from top right to bottom left. We call it the secondary diagonal. So 5 times negative 4, we end up with negative 20. We write it here, minus 3 times 3 is 9. So negative 20 minus 9, we are going to have negative 29. So negative 29 will be the determinant of this matrix. And then we are going to look for the inverse now. So for the inverse of a matrix, the formula is the reciprocal of the determinant, that is 1 over determinant, we open bracket, and then we are going to exchange the elements in the main diagonal. The last element become the first element, and the first element become the last element. So we had 5, 3, 3, negative 4. The first element was 5, and the last element was negative 4. So this negative 4 will take the first position, and the 5 will take the last position. So here we're going to have negative 4. We write it here. And then down we are going to have 5. We close the bracket. The elements in the secondary diagonal are going to remain in the same position. That is 3, and this is 3 also. But what will change will be their signs. It was positive, so it becomes negative. And this one was also positive, it changes to negative. So we are going to have 1 over. Our determinant is negative 29. We open bracket, negative 4, negative 3, and then negative 3, and lastly 5. So this is the inverse of this matrix here. Then the next step, we are going to multiply this inverse by the first matrix. So remember, an inverse times a given matrix, or a matrix times its inverse, it is equivalent to an identity matrix 1, 0, 0, 1. So there is no need for you to take this one to multiply it with this one again here. Instead, we are going to have this one, we multiply it by the constant matrix, which is 35 and negative 8. Because if we take this one times 5, 3, 3, negative 4, then we are sure that we are going to end up with an what is called an identity matrix 1, 0, 0, 1. So you just come here and say the unknowns are x and y. If I'm looking for x and y, it is equivalent to, so my inverse here is 1 over negative 29, and then I'm going to open a bracket. I'm going to open a bracket, and then this will be -4, -3, and -3, 5 as my inverse. And then I multiply this one by the constant matrix, which is 35, and then -8. 35 and -8. So it is like that. At this particular point, we are going to have -4 times 35, and then -3 times -8. This is how we multiply matrices. It will be -4 times 35. So -4 times 35, we are going to have -140. So here we are going to have xy in bracket. It is equivalent to 1 over -29 into, so we're going to have -140, and then plus -3 times -8, we're going to have +24. Write it here, +24. Close this bracket. And then -3 times 35. -3 times 35, we are going to end up with 105. -3 times 35, we are going to end up with -105. We write it here, -105. And then 5 times -8, it will be -40. So we add -40, like this. So for the numerator side, -140, when we add 24, we end up with -116. So we're going to have xy equals to -1 over 29 into -116. And then we close this bracket. For the denominator side, if we have -1 or 5, we add 40, or we add -40, that is, we are going to end up with -145. -145. So for you to get x and y, come here and see, for the x, it will be -1 over 29 times -116. So the negatives are going to cancel. We are going to remain with 116 as the numerator, divide by 29. These negatives are going to cancel, so we are going to remain with 116 divided by 29. That will give us 4. We are going to write 4. And then for the denominator side, -1 over 29 times -145, the negative and negative will cancel. We're going to have 145 divided by 29. This will give us 5. So for the value of x, it is going to be 4, whereas the value of y will be 5. So these are the possible values, that x is 4 and y is equivalent to 5. And y is equivalent to 5. This brings us to question number 13. So for question number 13, we are to expand and simplify. We are to expand and simplify. So for question 13, we are to expand and simplify. We are given an expression. And it is all about, we are given 2x plus 1 squared, and then plus x minus 1 into x minus 3. So we are to expand and simplify. To expand simply means to open the brackets. To expand means to open the brackets. So let us start with this one here, 2x plus 1 squared. So if we have 2x plus 1 squared, it is the same as having 2x plus 1 into another bracket, 2x plus 1. So 2x plus 1 into 2x plus 1. Or we can just obey the first quadratic identity, which states that a plus b squared, it is always equal to a squared plus 2ab plus b squared. So our a will be the first term given, which is 2x, and our b will be 1. So our a squared will be 2x squared, like this. And then plus 2ab, we are going to have 2 into our a is 2x, and our b is 1, bracket, and then plus b squared, which is 1 squared. So this will give us 2x squared. We are going to have 4x squared like this. And then 2 times 2 is 4, 4 times x is 4x, and 4x times 1 is 4x. So it will be plus 4x here, and then 1 squared is 1. So that is what we are going to have. If we have 2x plus 1 squared, the product will be 4x squared plus 4x plus 1. This will be the product. And then we come here and solve for this one here. We are given x minus 1 into x minus 3. So it is x multiplied by x. This will give us x squared. We write it here, x into x minus 3. And then this one is negative 1. We multiply negative 1 by what is in the second bracket, that is x minus 3. So as far as it is concerned, x times x, we are going to have x squared minus x times 3. This will be 3x minus 1 times x, we are going to have x. Negative 1 times negative 3, we are going to have positive 3. So this will be x squared minus 3x minus x, we're going to have minus 4x. These are like terms. And then plus 3. So we have this one and this one here. So I'll come here and say 4x squared plus 4x plus 1. We add this one to x squared minus 4x, like that. X squared minus 4x plus 3. So like terms. Here we have plus 4x and minus 4x will cancel. And then 4x squared plus x squared, we end up with 5x squared. And then positive 1 plus 3, this will be positive 4. So our last answer, our final answer will be 5x squared plus 4. We are going to have 5x squared plus 4. This brings us to question number 14. This brings us to question number 14. So for question number 14, we are to use mathematical tables to find the reciprocal of 0.0247. Hence, evaluate the cube root of 3.025 divided by 0.0247. Correct to 2 decimal places. Correct to 2 decimal places. So we are to use mathematical table. So for question number 14, this is what we are going to have. So what we are going to have, we need to appreciate how to look for reciprocals in mathematical tables, and also the cube root of numbers in mathematical tables. The cube root of numbers in mathematical tables. So for the first part, it is the cube root. We are to look for the cube root. The cube root of the numerator. And the numerator here is 3.025. So how do we get the cube root of 3.025? From mathematical tables. So as far as the table is concerned, we don't have cube roots. Instead, we have cubes. So we are going to use the table of cubes to come up with cube roots. We are going to use the table of cubes to come up with the cube root. So here I have a mathematical table. I've just downloaded this one from Play Store. So these are cubes. These are cubes. So the cube root of 3.025. For you to get the cube root of 3.025, you are looking for a number here inside this particular table, which is exactly 3.025, or a number which is slightly close to 3.025. So for that case, a number which is close to 3.025, it is 2.986. We have 2.986. It is this one here, 2.986. You see, the other number which comes immediately after 2.986 is 3.049, and 3.049 is greater than our number given as 3.025. So we are going to consider this number here, 2.986. So for the 2.986, if we move horizontally to the left hand side where we have x, the value of x corresponds to 1.4. We have 1.4 here. So here we have 1.4, and vertically from 2.986 we are going to obtain 4. So it simply means the cube root of 2.986, it is 1.44. So we'll come here and say I have 1.44, and this 1.44 is the cube root of 2.986. 2.986. And then you are going to ask yourself, from 3.025 or from 2.986, how many are we going to add to make it 3.025? We are going to do the subtraction. We take this number which is given here as 3.025, and then we subtract the 2.986 like this. So if we subtract here, we are going to end up with 39. We are going to end up with 39 as our number, 0.039. So if we have this 39 or 0.039, we are going to look for a number which is exactly 39 again, or a number which is close to 39 on the far right. So we had 2.986. So if we move 2.986, we are going to a number which is close to it, and the number is 38. 38 is close to 39. So we have 38 here, and vertically this number is 6. So we have to add 6. This number is 6. So we are going to add this number here, 6, to this one here, 1.44. So we are going to have 1.44, and then we add 6. So it will be 1.44 plus 6. The 6 will be here. That is 0.06. So if we add, this will be 10. So 0 carry 1 like that. And this will give us 5. And lastly, we're going to have 1. So we're going to have 1.50. We're going to have 1.50. So the 1.50 will be the cube root of 3.025. It will be the cube root of 3.025, just based on this mathematical table. And then we are to look for the reciprocal now of the number down, which is the denominator. Reciprocal now. Reciprocal. This number is 0.0247. So the reciprocal of this number, we are going to express it in standard form, and the standard form becomes 2.47. We are going to move how many steps? 1 to 2 steps towards the right. So it is times 10 power negative 2 times 10 power negative 2 times 10 power negative 2, like that. So if we have this number, we ask ourselves, what is the reciprocal of 2.47? So the reciprocal of 2.47, I have reciprocal tables here. The reciprocal of 2.47, reciprocal of numbers, for the reciprocal of numbers, this is what we are having. From mathematical table, the reciprocal of 2.47, let us consider its reciprocal. I've just downloaded this app. So the reciprocal of 2.47. So reciprocal of numbers, this is it. 2.47. We have 2.47. So 2.47 becomes 0.4049. This is it here. Up I have 7. 0.4049. So I'm going to have 0.4049. And then the reciprocal of 10 power negative 2 is the same as multiplied by 1 over 10 power negative 2. So this is what we are going to have. Reciprocal means 1 out of. So this will be, when I take 0.4049 times 1, we are going to have 0.4049. And down 10 power negative 2 is the same as 0.01. So if I take this divide by this, I'm going to end up with a number which is 40.49. So that becomes the reciprocal of 0.0247. 40.49. So I'm going to take this number, which was the numerator, 1.50, that is the cube root. I multiply it by 40.49. Remember, if this one was 0.0247, but its reciprocal is this one. So it is the same as taking this numerator number here, the cube root, which is this one, multiplied by this 40.49. So if I take 1.50, I multiply this one by 40.49, what am I going to end up with? So that will be my final answer. What is it? And remember, they are saying we have to express it correct to 2 decimal places. So 1.50 times 40.49, we are going to end up with 60.73. But look here. Here we had 1.44 and then 6. This 6, we were to add it like this, 1.44 plus 0.006. It should be 1.446, not 1.50, but instead it is 1.446 here, 1.446. So this one, it is just a correction, not 0.06, but 0.006. This is how we add. So if I write 1.446 here, and then I take this 1.446 times 40.49, final answer will be 1.446 times 40.49. I'm going to end up with 58.505. But they are saying correct to 2 decimal places, so it will be 58.51. So this one will be my final answer, 58.51. So that brings us to question number 15. So for question number 15, this is what we are having here. That a Kenyan businessman intended to buy goods worth $20,000 from South Africa. Calculate the value of the goods to the nearest South African rand, given that $1 is equivalent to 101.9378 Kenyan shillings and 1 South African rand is equivalent to 7.6326 Kenyan shillings. So for this question, it's all about conversions here, conversions of currencies. So the amount or the value of goods in US dollar was equivalent to $20,000. So 20,000 US dollars. We are to calculate the value of goods to the nearest South African rand. So here we have a relationship between US dollars and Kenyan shillings, and again we have a relationship between South African rand to Kenyan shillings. We don't have that relationship from US dollars direct to South African rand. So we have to convert these US dollars to Kenyan shillings first, and then what we are going to obtain as Kenyan shillings, we convert that denomination into South African rand. So if $1 is equivalent to 101.9378 Kenyan shillings. So we ask ourselves, what of 20,000 US dollars? So we are going to cross multiply. It is going to be 20,000 US dollars times 101.9378 Kenyan shillings, all this divided by $1. So for the US dollar and the US dollar, they are going to cancel like this. So we remain with Kenyan shillings. So if we take 20,000, we multiply it by 101.9378. We are going to end up with 2,000,000. We are going to end up with 2,038,700 756. This one is Kenyan shillings. 2,038,756 Kenyan shillings. Again, we convert these Kenyan shillings into South African rand using this relationship here, that 1 South African rand, it is equivalent to 7.6326 Kenyan shillings. Then what of, we now have 2,038,756 Kenyan shillings. We cross multiply. So this will be division. It is going to be 1 times 2,038,756, all this over 7.6326, like that. So the Kenyan shillings and Kenyan shillings will cancel. We are going to remain with South African rands. So if we divide our answer by 7.6326, we are going to end up with a value which is equal to 267,111.60. They are saying calculate the value of goods to the nearest South African. So if it is to the nearest South African rand, we consider this digit which comes immediately after the decimal. If it is 5 and greater than 5, so this number will be affected. We are going to add 1 to this number. And if this is less than 5, this number will remain the same. So this is 6. So 6 will make this one to be 267. Instead of 111, we end up with 112 South African rands. So our final answer will be 26,000, not 26,000, but 267,112 South African rands. That brings us to question number 16. And this is the last question in section 1. Question number 16. The question reads, a photograph print measures 24 centimeters by 15 centimeters is enclosed in a frame. A uniform space of width x centimeter is left in between the edges of the photograph and the frame. If the area of the space is 270 centimeters square, find the value of x. So here we need to have a sketch. We need to have a space. So this one is the it is the frame together with the photograph print or the photograph. So this one is the frame. A photograph print measures 24 by 15 is enclosed in a frame. So we can just have it like this. So the photograph print is the one which is inside the frame. It is enclosed in a frame. So this is the frame. This is the frame. And this one here is the print, the photograph print. The print measures 24 centimeters by 15. So here we have 24 and here we have 15. We are being told that a uniform space of width x centimeter is left between the edge of the photograph print and the frame. So we have this space here between the print and the frame. This is the space they are talking about. They are saying that this space measures x centimeters. It is uniform. So we have x up and we have x down. Towards the right we have x, and towards the left we also have x. They are saying if the area of the space is 270 centimeters square, find the value of x. So the area of this shaded part, the space is 270. So how do you get the area? It is the total area minus the area of the print. The print is inside. The total area minus the area of the print. So for you to get the total area here, you should be aware that this distance from here up to here will be larger than this distance from here to here. So if from here up to here is 24 centimeters, and then we have x towards the right and x towards the left, x plus x is 2x. So for the entire length outside, it is going to be 24, and then we add 2x like this. And for the width, if from here up to here was 15, I have x towards the bottom and x towards the top. So x plus x is 2x, and this one is 15. So it will be 15 plus 2x. I write it here, 15 plus 2x. 15 plus 2x. So again, I will come here and say the total area is 24 length times width, that is plus 2x, into another bracket 15 plus 2x. That is the total area. This one is L for the length and this one is W for the width. Remember, area of a rectangle is length times width. So what is the total area here? So 24 times 15, we are going to have 24. Here we are going to write 24 into bracket what is inside the second bracket, that is 15 plus 2x. Here we are expanding. Then close bracket. What is remaining here is positive 2x into 15 plus 2x. So this one is the entire area. So 24 times 15, we're going to have 360. I write it here, 360. And then plus 24 times 2x, this will be 48x. And then plus 2x times 15, this one will be 30x. Plus 2x times 2x, this will be 4x squared. So like terms, for the like terms, I'm going to have 48x plus 30x, that will be 78x. So I write 360 here, 360, and then plus, this will be 78x, and then plus 4x squared. This one was the total area, area. And then area of print, area of the photograph print. So area of the print, it is length times width. Length is 24 and width is 15. So it will be 24 times 15. So if I take 24 times 15, I end up with 360 centimeters square. So they're saying, if the area of the space, this space here is 270. So if we get the difference between this one and this one, we take the total area minus the area of the print, then we are going to have the area of the space. So total area minus area of print should be the area of space. The total area 360 plus 78x plus 4x squared. And then we are going to subtract 360, that is the area of the print. So what are we going to have? This 360 will subtract 360, so we are going to remain with 78x plus 4x squared. And then the equivalent answer will be 270, because this 270 is the area of the space given, 270, like that. So at this point, what do we do? So we are going to form what is called a quadratic equation. We are going to form a quadratic equation. And for that quadratic equation, we know very well that it should be in the form ax squared plus bx plus c is equals to 0. So we take this one to this side, and we rearrange this one such that this one with the x squared take the first position. So it will be 4x squared plus 78x. And then if we take this negative to this, positive to this side, it turns to be negative 270 is equal to 0, like this, equal to 0. So we can divide all these ones by 2 because they are divided by 2. So if we divide this one by 2, we divide this one by 2, we divide this one by 2, and this one by 2 to simplify it, this will be 2x squared. Going to have 2x squared plus 39x, write it here, and then minus. So what is 270 divided by 2? We are going to have 135 is equal to 0. So we can look for x here. So x, by quadratic equation or the quadratic formula, the value of x is always given by negative b plus or minus square root of b squared minus 4ac, all this divided by 2a. This one is the quadratic formula. So we need to identify our A. Our A is this one here. It is 2, that is coefficient. My B is 39. And my C is equivalent to negative. C is negative here, so negative 135. Write it here. So negative B will be negative 39 plus or minus B squared, that is 39 squared, square root of 39 squared. So 39 squared is the same as 39 times 39, which will give us 1404. 39, not 1404, sorry, but 39 times 39, we should get 1500, and this one is 500, 1521. 1500. So this is negative 39 plus or minus square root of, it should be 1521. And then minus 4 is C. So because C is negative, these two negatives will change to be positive. Because here we have negative 4, and then times A, the value of A is 2, and then times C, which is negative 135. So negative 4 times 2, we are going to have negative 8. Negative 4 times A, that is negative 4 times 2, negative 8. And negative 8 times negative 135, negative 8 times negative 135, we are going to end up with 1080 positive. 1080. And then all this, you divide this one by 2A. So our A is 2. So 2 times 2 will be 4. 2 times 2 will be 4. So let us work out inside here. 1521 plus 1080. We are going to have 2601. So this will be negative 39 plus or minus the square root of 2601, and all this divided by 4. So we should ask ourselves, what is the square root of 2601? 2601. The square root is 51, so this will be negative 39 plus or minus 51, all this over 4. So we need the positive side. We need a positive value because x is a length and length is always positive. So we take negative 39 plus 51. Negative 39 plus 51. We end up with 12. So it will be 12 all over 4. So if 12 is divided by 4, the value of x becomes 3 centimeter. The value of x becomes 3 centimeter. And that is it. So up to that point, we are done with section 1. What is remaining is the construction part, which was question number 7, but we shall later come and discuss about it.